name is Suveer. I work in the Nonstop Enterprise Lab of Hewlett-Packard Enterprise. We develop mission-critical servers, and then Nonstop is one of the mission-critical servers that Hewlett-Packard Enterprise offers. My talk might be a little bit different, but I'll try to relate to what a normal user of Redis expects from the product, and then relate my experiences with Redis to that. We started our tryst with Redis about 3 years back. We are not users of Redis, but we are providers of Redis. So we provide Redis as an infrastructure component of our Nonstop servers. Okay. What I mean by that is we took open source Redis. Open source Redis, we started with 2.8.9, and then currently we are working on 4.0, and then we have provided enterprise capabilities to the open source Redis. So in the process, most of you might know, might have worked on the open source Redis. There are some enterprise features that are missing that we heard are available in the enterprise Redis that is offered by Redis Labs. We have taken the open source Redis, put in a lot of enterprise features, and then platform-specific customizations to make it enterprise class. So during this talk, you will hear a lot of performance-specific stuff. I'll talk about some internals of Redis, not about the data structures, about internals of Redis that might be of some use to you when you start designing a Redis system for production use. Okay? But before that, as is the custom, I'll speak a little bit about Nonstop servers. Nonstop servers, they provide 7 nines of availability. Okay? So that means a maximum of 23 minutes of downtime the entire year, planned or unplanned downtime. Okay? It is used across, it is 6 minutes. 6 minutes of downtime the entire year, planned or unplanned. And it is not an SMP architecture, it is a massively parallel architecture. So what I mean by that is one chassis of Nonstop will have minimum of 2 CPUs, maximum of 16 CPUs, can be extended to 4,050 CPUs. Okay? So if I have a software that is running on Nonstop, it is meant to be hardware fault tolerant. So if I just plug out a CPU, the software should not stop. It should be the service should be continuously available, and it is software fault tolerant. But we are present in a lot of different industries, and then all our customers expect that their service is available 24/7. Okay. Now, how does Redis fit into this picture? See, you all are aware of what Sentinel does, and then the master-slave configuration does. Okay? We took the features of the purpose of Sentinel, or the end goal of Sentinel. We took that end goal of master-slave, we converted that to a platform-specific technology called as process pair. Okay? So a process pair is nothing but, at any given time, an instance of Redis comprises 2 processes. Okay, one a primary and a backup. It is very similar to master-slave, but it has got a lot of platform-specific technologies built in. So what that means is, if you bring down a CPU where the master is running, the slave automatically takes over. More importantly, we guarantee 100% data consistency. It is actually 100%. It is not an exaggeration. It is 100% data consistency. So in this slide, I will not talk about the Nonstop specific features, but I will talk about what features of Redis and internals of Redis that enabled to give you a product based on Redis that will give you 100% data consistency, and with data sizes of 50 to 60 GB we have tested, a failover time ranging from a few milliseconds to about 30 seconds. So we tested the failover of 60 GB of data. The failover time was about 30 seconds with 0 data loss, and with data sizes of less than 1 GB, the failover was less than a few milliseconds. Okay. If you see Redis, if you see the Redis code, you will see something called as an event loop. Okay, you will see something called as an event loop. The way Redis is designed is no operation is blocked. That includes the write operations to the client. So only when the client is ready to receive data will data be written. Okay? This very elegant piece of Redis infrastructure gives you lots of insights into how you can gauge the performance of Redis when you are planning for a production deployment. I'll give you an example. You must have measured how long a particular command takes. Okay, let's take a set command. A set command takes about, we have measured it, it takes about 4 to 8 microseconds. It takes about 4 to 8 microseconds, a set command. Okay? But the response that you see in the client is not in microseconds. It's in hundreds of microseconds. Okay, so where did 4 microseconds or 8 microseconds become 200 to 300 microseconds? I'm talking of the 300 microseconds in a private network. Okay, so this is where the knowledge of the event loop comes into play. If you have only one user, okay, one user connected to Redis, one client connected to Redis, even then you will see such big latencies. So there is obviously a network latency. Okay, but the surprising thing is you connect 100 clients, the chances are all the 100 clients get to see the same latency up to a certain level, up to a certain limit. Okay, that's the beauty of Redis internal event loop. Okay, so what you see the discussion point, IO-based multi-threading. I'm sure you all are aware of this. It does not use threads, but then it is actually multi-threaded in the sense that it does multi-threading based on IOs. Okay, and then it gives fair treatment to all the clients. Now, what this means, if you have a client that wants to set 1 MB of data, and then if you have a client that wants to set only 1 KB of data, the client that wants to set 1 MB of data will not block the client that wants to set 1 KB of data. That is a fair treatment that Redis gives. Okay, this will not be evident to normal programmers or users of Redis. This will not be evident at all. This will become evident once you start planning a production configuration and you want to decide how many clients you can connect to a Redis instance without compromising on your SLAs, service level agreements. Okay, how we used this particular feature in our process pair. Okay. Meanwhile, if you have any questions, please do stop me. Shripati asked me to go through the presentation for 15 minutes and then keep the last 10 minutes for questions. But if you have questions, please do let me know. Okay. Now, how we have used this particular feature of Redis, that is the event loop characteristics, where no operation gets blocked. Okay, and an IO operation happens only when the IO is ready for that operation. Okay, how we have used that is, I'll give you some statistics. In master slave, or process pair is equivalent to master slave in the enterprise Redis, we do synchronous replication. Unlike what you heard from Redis Labs, they do asynchronous replication between master and slave. We do synchronous replication between master and slave, yet we don't compromise on the throughput or the latency. Okay? We don't compromise on the throughput and latency. There is a small drop in throughput, about 0.5 or 1% drop in the throughput when I am using the master-slave equivalent, that is a process pair on nonstop. Now, this is possible because of the event loop architecture of Redis, right? Now, probably I'll stop here for a minute. I'm not sure how, I heard a lot of questions regarding the usage of Redis the last 1 hour. So this might be a shift in what you are hearing. You are hearing about how Redis internally works and then how we have harnessed the wonderful architecture of Redis, that is the program architecture of Redis to provide enterprise characteristics on open source Redis. Okay. I've got a few more slides, but then they will all be around the same topic of explaining the internal characteristics of Redis and then how we have harnessed. Okay. Oops. Now, we have actually turned off AOF, append-only files. Okay. And in spite of that, we don't lose data. So in all the installations so far we have got, we have not lost a single byte of data. And then we don't use AOF, and then we don't use RDB. RDB is used only when we want to bring down the entire system. Okay. I'll talk about our take on AOF. This need not be you may have different sentiments about AOF, you may have different sentiments about RDB, but this is just our take. AOF, we have seen, is probably not the best option if you are using Redis as a cache. Very simple. I'll give you one example where some of our customers use Redis to store the state of an application server. Take JBoss or take Tomcat. You want to store the state of an application server. Okay? There, let's take the example of simple HTTP sessions. HTTP session keeps changing with every request. With every HTTP request, the HTTP session changes because the last access time changes. Okay? Does it make sense to have one record in AOF for each of that change and then put a tremendous amount of load on your file system to store all those records? Probably not. We have seen drop in performance when we enable AOF. Okay? So what we have done is we have used something called as a checkpoint technology of nonstop, where we accumulate all the write operations within an event loop and then checkpoint in one shot. Okay? So just a quick show of hands, how many of you have seen Redis internal code? 1, 2, good, 3. So for the benefit of the others, does it help if I explain the event loop, what that means? Yeah, good, okay. Because the next slide also talks about the event loop, and then the last slide I'm going to talk about some of the use cases, some unique use cases that we have found. I should have asked this question earlier, anyway. See, event loop is the IO-based multi-threading is based on either the select call or the poll. So these are the two popular polling mechanisms available in star Nix operating systems, right? Select and then poll. What Redis does is, when Redis starts, it opens up the server port, waits on the polling mechanism, select, okay? And then it waits for the connection. The moment a connection comes, the select comes out or the polling mechanism comes out, and then it handles that request. While handling, that is that event loop, while it is handling, it does absolutely no I/O. But it indicates that it is, the event loop indicates that it intends to do an I/O. What it means is, if a client has connected, the first thing the Redis server does is it will post that it is interested in reading from the client. It does not block on the read. It says that it is interested to read from the client. So only when there is data, the polling mechanism comes out, okay? And then the read call is not blocking. That is how Redis works as a non-blocking server. You able to follow me so far? Yeah? The most important thing to understand here is the read and then the write calls. These are the I/O operations. The rest are CPU-intensive operations. Redis does mainly two operations, I/O operations and then the CPU-intensive operations. I/O operations are the only network operations that happen to the clients, other than RDB and then AOF. Let's leave out RDB and AOF for now. Okay? Now, the point is Redis should not block on those I/O calls. That is, I/O calls are primarily read and write. It should not block. So Redis internally, the event loop says that it is interested in a read operation. So the select says that something is read ready. So when it is read ready, the read call will never block because the data is already there. It reads immediately. And after the operation is done, it does not write immediately. It says that it wants an intimation for write readiness of the client or write readiness of the socket. Okay? So the next time it goes to select or the polling mechanism, that's when the write readiness is indicated. You're able to follow me? Yeah? The write readiness is indicated. Redis does not assume that a particular I/O channel is either read ready or write ready. It does not assume that. Okay? It expects the operating system to tell whether a read channel or a I/O channel is ready for reading or writing. So this ensures that Redis does not block on I/O. Now we have harnessed that particular feature. Okay? So what this means is, in an event loop, if you have 100 clients, all the 100 clients are serviced in one shot without doing any I/O. Mind you, without doing any I/O. All the 100 clients, the operations are done, and then the I/O happens. You got that? So internally, if you see, if there are 100 clients and each of them is doing a set operation, all the 100 operations will actually get over in 500 microseconds. 100 into approximately 5. All the operations actually get over in 500 microseconds. Okay? And then all the writes happen, one after the other. That's the reason you actually see that the clients, whether it is 1 or 100 up to a limit, will not see a difference in the response times by adding new clients. So there is a capacity, there is a limit to this. You cannot add, let's say, 1 million clients to one instance of Redis and then expect the same response time, right? So this understanding of the event loop probably might have given some of you some insights into how to size an instance of Redis. How to size an instance of Redis. I'll also talk about some of the features that are sorely missed when you want to use Redis in an enterprise. Okay? This particular feature, now I told you about the event loop. Okay? Now in this event loop, what we have done, within the event loop, we have implemented the checkpoint technology. Yeah? Pardon me? Well, that's the design of Redis. See, if you read Antares blogs, he clearly, he has done some POCs and then shown that if you use threads, as in kernel level threads, we all are used to threads, correlating threads as kernel level threads. You use the pthread library and all those things, and then you expect the threads to run in different cores, right? Now, Redis has got a single database, and then if you want all the threads to access that single database, you need to have locks, right? So the cost of acquiring and releasing a lock, 5 more minutes, I have a few more slides. Okay. So the cost of acquiring a lock and then releasing a lock is much more, okay, than operating on a single core and then do I/O-based multi-threading. Okay, that's the reason Redis does not use cores, does not use threads, and it relies on I/O-based multi-threading. Okay, now this knowledge, we use this knowledge to do the checkpointing, and I can say that we score over open source Redis. I have not seen enterprise Redis in that even if we have tested with 500 clients, 1,000 clients per instance, the overhead of checkpointing is less than a microsecond for us per client. So this internal architecture of Redis helped us design an enterprise class Redis using open source Redis, where we provide 100% data consistency, yet no overheads on the response time. Now regarding AOF, I already hinted that we don't, at least in our deployments, we don't support AOF simply because of the checkpointing technology. You always have the data readily available on a different CPU on a different process. You have a master slave, so the data is already always available. So we don't need the data to be persisted to disk to be consistent. And then we have also measured, there are a lot of blogs by Salvatore where he talks about how persisting to files is OS specific. Okay? Some OS have got huge file system caches, some don't have, some persist to disk immediately. That cannot be controlled. There is no open API that can control that. Okay? Oops. Now, there is one feature that we have built. Yeah?
In the event loop, when it goes to write, does that, you said that will not block?
That will not block, yeah.
What if I'm writing a large payload?
No, it will not. That's why, okay. Now, see, fair treatment of all clients. I told only a part of that fair treatment of all clients. Every I/O is in chunks of 16K within Redis. Even if you want to write 1 MB, Redis gives a fair treatment by writing it in 16K chunks. Okay, so it does not write 1 MB in one shot. It writes it in 16K chunks. So that's a fair treatment offered to all the clients.
And does the Redis instance have core affinity? Will it get context switched out by the OS?
It depends on the OS. For example, in some of the HP UX operating systems and the non-stop operating systems, I can assign a priority to a process just like other operating systems. If it's a higher priority, it'll just run. Okay. Now, some of the interesting things will come in the future slides. I'll skip this because we have introduced a platform-specific feature which can accurately measure the time taken by each operation. There are about 80 commands in Redis, 80 or 90 commands in Redis. This infrastructure can measure the time in microsecond precision for each command. And then we also have infrastructure to see how the database grows, the size of the database grows, and then how the eviction algorithm kicks in, and then what are the overheads of the eviction. You need to be aware of all these things if you are designing a production system. You need to be aware what is the eviction algorithm you are going to set, and then what is the overhead of the eviction algorithm, how many keys are getting evicted. Probably these are some of the statistics given by the enterprise version of Redis, but then you don't get too many of the statistics in the open source version. Okay, I'll skip this slide. Probably I can talk a lot more about this later. Sripati and I, we decided probably I should talk more about some of the use cases. See, we are doing a lot of POCs on how Redis can enable a microservices kind of architecture. Okay, this is one way of enabling a microservices kind of architecture. In microservices, as most of you will know, we don't expose the databases or the data store of one set of microservices with other set of microservices. You don't share anything, but yet they have to be working on the same set of data. Okay, so here this is a classic example of combining a NoSQL database like Redis with a traditional RDBMS database. We have a POC running in our HP nonstop labs for this, and we take the audit logs real time from the RDBMS data, from the RDBMS, the conventional database, and then we transform the data to a readily consumable format like a JSON format. Like the format in which the data is stored in a traditional database is not a document format. So we convert it to a document format and then push it to Redis. Okay. So in this case, let me see if I've got a pointer here. The top one. Yeah. So here, a set of microservices access RDBMS. They are not given access to the NoSQL. A set of microservices are given access to NoSQL, and then the extractor and then the algorithm that transforms the RDBMS audit logs to NoSQL, takes out data that should not be visible to the microservices here. Now, another use case of Redis replication is you can make multiple copies of this data and then scale out. Now, in this case, what we have done is there is a very unique solution that we are working on. You must have heard of the Great Migration in China. Okay, that happens on the Chinese New Year day. The Chinese railways, they have to contend with about 40 million ticket bookings in an hour. 40 million ticket bookings in an hour, okay? That is the number of bookings. Now imagine how many times a client will check whether a ticket is available, AC class is available, first class is available. So the number of read operations is about 100 to 200 times than the booking operation. These are real-time statistics. So if you put the entire load on the RDBMS, it's going to crash. Okay? So this solution, where we have the read data readily available in Redis, real time, okay? And then the write data, that is if you want to do a booking, that has to be committed, that data goes here. But if you want to check the availability of seats or the class and reservation and all those things, that can be read from NoSQL or Redis, okay? Now this solution, along with the replication feature of Redis, it is extremely easy to scale. Now we are talking of 40 million into 100, okay? About 4 billion read operations an hour, okay? Extremely easy to scale. And then in our own test environment, we have seen up to 70,000 transactions per second with 1,000 users connected to a single instance of Redis without missing the SLA. SLA is service level agreement, without missing that SLA with the process pair architecture of nonstop, where there is no data loss. At the same time, we see transaction rates of up to 70,000 transactions per second. Okay? Now I can go on and on about the internals of Redis because I've gone through the code and then. Oh yeah, okay, sure. So I'll just stop at this because, yeah.
How do you send the data from RDBMS to NoSQL in real time?
Real time, okay. See, a lot of RDBMS, they store data in audit logs. The audit logs obviously have to be updated when data is committed, okay? And the databases that I know, they give you features, API features, that is a push mechanism from the audit logs to an application. So when an operation happens, when an IUD operation, insert, update, and delete operation happens, the audit log actually gets updated, and with every update, this is an database-specific feature where I know some of the databases that we work on, they provide an API that gets a notification that something has changed. Okay? So we take the data and we massage the data. That is, we transform the data, okay, and then push it to NoSQL. Okay? In fact, this is where we are using modules. We are using Redis modules here so that the audit extractor just pushes the data. Okay? The module massages or transforms the data to a JSON format and then updates just the part of the JSON document. So this, for your short answer to your question, is extracting audit logs from an RDBMS is an RDBMS specific feature that cannot be generalized across the databases. You might have something specific for NoSQL or MySQL, something for Oracle, something for SQLMX.